If we can't win it, then somebody else might win it.
This space is moving so rapidly that best moat is going to be rapid innovation, being able to move faster than anybody else. We're the first people to sit here and kind of release a measurable, machine learning driven capture system for the phone.
Everything should be done on the device. Not always going to make all the decisions, but at least it's going to really drive the efficiency of the workflow by taking out all that human labor.
Look is building the data mesh to be able to inform where in the future do we need to go. And that is the utilities that care about that. On a set of projects, prove the value, make them love it, make them live so that they can't live a second without it.
We are excited to come up and talk to you about our first year of RCN Ignite, which is our startup pitch competition. And to us, this is another thing that we're launching in an effort to try to build the community, empower people that are creating products, creating solutions. Right? We're building awareness. We have the eyeballs of a global audience, so why not use this as an opportunity to show off things that people in this industry are being creative with. This year, we have Power Engineers as our main partner and sponsor for this event. So I've got Will up here to talk to you a little bit about why they're here, why they believe in this, and we're going to tell you a little bit about the startups that are pitching and the judges that will be here as well. So I'm going to hand it off to Will to talk a little bit.
Thanks, Matt. So I want to welcome everybody today. Thank you for coming. This is the first time Power has sponsored an event like this. So I love, one of my friends has a coda in his iPhone text that says, "Please read forgivingly." So apologies in advance if there's any rough spots. But thank you again for coming. We've got 3 great startups pitching today. 4 judges in front of you, which I'll introduce in a second. And I think, let's see, we've got a decently full house here. Please make sure, if you can, to come back 1:30 tomorrow afternoon, where we'll do the award. All right, so bring noisemakers, bring hands, ready to clap, ready to make some noise, because these guys really did a great effort to apply and to come and pitch in front of you. So I'm thanking them in advance, and I want your help to appreciate them on Thursday. I also want to thank the entrants who aren't on stage today. We had a great crop of entrants. People put forward a lot of great material, great ideas. We're very impressed. It was very inspiring to see both where people have achieved, where they've got to today, but also where they're headed. I don't want to take too much time to talk about ourselves, but a little bit of a sense of how Power looks at the reality capture space and this challenge. And then I'll get straight into introducing the startups. Power Engineers was founded in Idaho almost 50 years ago. We've been an employee-owned company for that whole time. As of this month, we were purchased or acquired by WSP, one of the largest engineering companies in the world, which is delightful, right? It's a massive opportunity for both companies. It's fantastic. We think about this reality capture problem in similar ways to what we've heard this week, but also there's an added element that I want to bring to the fore here, and it actually comes from several of our backgrounds on the team. It's sort of clear that good capture is useful for design, and it creates value for owners, and it can create value for users, and it creates value for constructors. But one of the things that WSP and Power really spend a lot of time and effort on, where we earn a lot of our money, is in infrastructure projects. And we can't do an infrastructure project in the Western world without social permission. That is fundamental to getting the money spent, getting the projects built. And it is fundamental to any kind of energy transition that we imagine we're going to achieve. Right? The local opposition, backyard opposition, whatever you want to call it, but the lack of social permission is one of the biggest obstacles we have to building anything new or large, both in the States and everywhere else, frankly. We were just talking about that in the green room, right? Who's going to win the ability to host nuclear power? If we can't win it, then somebody else might win it. So we think about this as a communications tool, right? Dan Kretz is in the front row here. He runs our visualization division at Power. And one of the most important things that his group does is help lay people understand what we're trying to promote. Like, what is the design? We've captured this site. It's going to cross this river, this creek. It's going to skirt this cemetery. But how's it going to do it? right? So it's useful for the designer, but it's also useful for the regulator, the citizen who ends up paying that bill. So I wanted to emphasize that third layer of user, which is the layman, right? It's cosmetologists and musicians and people who don't ever have a CAD license, but still have a massive interest in the things we're trying to do. And they control whether the projects we're built to design ever get funded. So without any more ado, I want to introduce our 3 startups. First, we'll hear from Eric Peterson of Manifold, then Pat Lohman from Clonable, and Dom Meyer from Look. And then the judges in the front row, I'll ask you guys to stand up because you're a little hard to see for the guys in the back. If you guys could stand up and do a little twirl for us, and then raise your hand when I call your name. Jason Pav, my boss, Chief Innovation Officer for Power Engineers, Russell Sproul, Verta Ventures, Curtis Rogers, Brick and Mortar Ventures, and then Josh DeStefano, DPR Construction. So Eric, if you're back there, I'll pass the mic to you, but thanks all for being here, and I look forward to the pitches.
Yeah.
Hi, everybody. I'm Eric Peterson. I'm the founder of Manifold. And first off, I just want to say thanks to the RCN team and to the Power Engineers team. I want to introduce you to Jake to start this off. So he's an HVAC guy in New York, and he used to go on site and take dozens of measurements for every single unit that they would replace or fix. And now he's moved to the point where he's basically taking 30 seconds of video in our app. And he trusts it enough at this point that he actually stopped taking any other measurements, which is not something we told him to do. It's something that he started to do because it was so easy. So Jake is living in a new world. It's a new world of machine learning-driven AI. So basically, 3D reconstruction is going to go through a big shift, just like we've seen in other fields. You know, like image recognition, chatbots, we've all seen like this rapid progress happen. 3D reconstruction is no different, and in fact, it's very similar because it has tons of data, tons of image data. And so it's a perfect fit for AI to handle that data and do a better job of reconstruction. And machine learning, in a broader sense, it's kind of a broad term, but really that's what's working at this NeRF and Gaussian splat technology that we've seen kind of take over visualization in a dramatic fashion. And everyone's underestimating the impact that this technology is going to have because it is not visualization, it is 3D reconstruction. I'm actually going to do a talk tomorrow at 4 p.m., so you guys should come see that because I'm going to go into deep detail on the technical side. But this is what we're seeing on the visualization side right now. It's dramatic, the difference that you can have when you're dealing with machine learning doing your 3D reconstruction versus older techniques like photogrammetry. Like this stuff looks like video, right? But this is all Gaussian splats, NeRFs that have been reconstructed from just images, no LiDAR. So planoptic 3D learning is really what you could call this. Essentially, it's taking machine learning and then it's taking the image data in and then it's using every single pixel to do the reconstruction. But the most important thing is that it scales with compute. So it's theoretically limitless. It also means that you can kind of decide how much compute you want to put into it. But the idea being that we're now in this position where 3D reconstruction has AI integrated from the ground up, not kind of as an afterthought after the scanning has happened. And so we've been building for this tech for 4 years. As soon as that NeRF paper dropped, we were pumped and we've been building for it. And so we've been looking forward to this new world. And the key to the new world is that every single phone on site is now going to be able to do high quality 3D capture. And it doesn't have to have insane resolution. It doesn't have to have LiDAR. It's going to be measurable. Every team is going to be able to capture their own work because of that. So it's going to completely shift how things are done on site. You're going to be able to update digital twin real time as a team. And eventually, you're going to see every single photo, 360 image, all be contributing to this digital twin. So you can accelerate tons of things on site. You can accelerate your takeoffs, your payments, inspections. Everything that happens on the site can now essentially be accelerated. And we're also going to see a ton of low-cost, low-res drones start to take over the 3D capture space instead of having these really expensive, high-resolution rigs that have been doing it. So let's go back to Jake for a second and talk about the impact this has had on him. So he can now afford to take 3D captures, which he's never done in the past. And so what that means is he has less people who go on site to take his quotes, which means they're spending less time, which means he can do more. So he's almost doubled his quote volumes in terms of being able to go out on site and talk to people about fixing their issues. And he's impressing everybody, right? Like he's able to send these 3D renders that look photorealistic with measurements to his engineers, and they're able to take this data off and then use it for their work. So let's talk a little bit then about us, Manifold. So we've been in the market and we've been serving, more than 40 teams. We've started with LiDAR on the iPhone and iPad. We've been doing a lot of auto registration with that data, so we have a lot of experience taking phone data and turning it into something that's a little bit more industrial scale usable. So we've been in the market for 2 years. In the last year, we've seen 300% revenue growth. We're going to be profitable in 2025. We have a lean team, so it's a really, low cost approach. And based on our tests so far with Orbit Measure, which is what we're calling this feature, it's definitely going to be our main driver of sales. We've had a ton of positive feedback for it. Understanding how we grow right now, it's a two-pronged approach. We do stuff like this, where we go out and talk to people about tech and get connected to larger companies, but we also have self-serve, Google Ads, bringing in small businesses. And this is something that I think, you don't see a lot of in this space, and something that we have always been pushing for, which is we want to democratize this technology and bring it to the long tail of construction, which we all know is much bigger in a lot of ways than the kind of head, because it's just such a huge industry. And so much of the industry is left out of this 3D data capture. And we're really doing that by building small first, so making small teams functional with the data, and then allowing ourselves to grow it for the bigger teams, adding features on top. So in terms of our team, myself, I am clearly a product guy, talking way too much about tech. We've got another strong engineer, Yishwan, who's been on the team for a while, and Alana, who's kind of our marketing guru and has set up our Google ad, input and everything. And so it's a really strong core team. We've been surrounding ourselves with contractors to grow when we do. That's us, and I'm looking forward to talking more, and hopefully you guys will come Thursday and hear the talk at 4 p.m. so I can give you a little more info on the technical side. But yeah, and if you've been noticing, we have a couple QR codes. That's for the app download on the left. On the right, if you want to get access to this new feature, you have to add yourself to the project for RCN. We have a special project set up for RCN. So you can use the new feature while you're here on the project site. So that's me. I guess we're going to questions.
Hello, thank you. This is Curtis from Brick and Mortar Ventures.
Hey.
My question is, for your founding team, what is the management experience of that team? Have they built teams before, hired and fired, P&L, that type of experience?
Yeah, so I think that the main management experience is with myself in terms of my work at Goldman Sachs. We had a tech team that we built up for managing their derivative products pre-market crash. So it was an interesting experience, but we were kind of like almost a SWAT team for tech. And so we brought in folks from Japan and London, and then we'd essentially go into these systems when they were releasing new products, because usually the math was too complicated for most of their programmers. And so we would kind of do a bridge between their strats, which are the mathematicians, and their technical team. But yeah, that's kind of the management experience.
Thanks, Eric. Can you talk a little bit more about the competitive set in this space? Are there any other solutions out there, either specifically for your users today or things that are more horizontal focused, and how are you kind of creating defensibility and differentiation within that?
Well, to be honest with you, this space is moving so rapidly that I think the best moat is going to be rapid innovation, being able to move faster than anybody else. We're the first people to sit here and kind of release a measurable, machine learning driven capture system for the phone. And I think we are probably going to be the first to integrate that into, a number of other input devices. But I think the key is going to be, focusing on your customer and then building a specific set of tools for those people. And I'll go back to the machine learning side of things here, because you may think like, this kind of 3D reconstruction, it's going to be really general. It's going to everyone's going to want it. It's going to be really useful. But there are going to be things about it that are going to be most important to integrate for construction. And because it is machine learning from the ground up for AI, we are very focused on building our next set of features, which means modifying that code so that with the inputs that go into the machine learning process and come out the other end are specific to our customers and specific to our industry, so we can kind of build that moat. I would say the main competitors in the space right now are like Illuma AI or a Polycam. They are doing this well in a general sense for a more hobbyist audience, I would say. But they don't do a good job of integrating, building GPS-based projects, sharing between teams, managing, and all these construction tools that people do need. And so I think the other side of it is we are focusing on a non-tech savvy audience. And so we're building easy to use tools so that a guy like Jake, who, is not a tech guy, basically an HVAC guy, can set all this up by himself without even talking to me.
I got a question for you, Eric. I think you've done a great job, by the way. This is really cool. I'm a huge fan of Gaussian Splat. I think it's amazing from the world of visualization, and I think it does a really good job of visualizing them with AI cleaning it up. Awesome. Here's my challenge with Gaussian Splat, though, is that we work in the AEC space, and a lot of times we have to take this information and give it to an engineer for takeoff. Mm-hmm. And the challenge I've seen is converting Gaussian Splat models into polyface models, true polyface models that are accurate. Is on your roadmap, are you guys working on conversion from Gaussian Splat to true 3D polyface models for visualization engineering?
Yeah,
Just curious.
It's a great question. Very knowledge-based, knowing what the problems are in the field. So solid. There are already approaches that can do this now. Essentially, so come to the talk tomorrow. I'm going to explain this all, I promise. But basically, if you use surfals, which are surface estimates, instead of splats, when you're doing your reconstruction, then you essentially end up with full normals of the whole surface, and then it's a easy export. And the one thing to note here, though, and this is going to come up in the talk, meshes are not it. This is going to replace meshes.
I'm glad you said that, actually. That's cool. Thank you.
Good afternoon. Before I talk about what we do at Clonable, I wanted to take a couple minutes to talk about why, because it really drove our purpose to start the company and keep running with it. Myself, along with the other two co-founders, we've been working together for the past 12 years. Previously, we helped build and grow a company in the reality capture space, primarily for large enterprises. So we were working in oil and gas, electric, telecom, a little bit of AEC. And I think once we eventually exited and got out of that company, we were trying to figure out what were the biggest systemic problems that we could solve next. And the biggest one that we saw was operational scale. So no matter what the application was or the use case or the industry, whether we were doing inspections, digital twins, or maps, we always saw this kind of same workflow, which I'm sure most of you are familiar with. Go out and collect all this data in the field, make sure was a good collection, move that up to the cloud. An analyst is using it to either do things manually, or they're using other software packages to run it through. Maybe they're building some scripts to turn it into something very specific for the client. and then they're handing it over to the client to kind of make decisions off of. And it worked great for projects when we were doing hundreds or maybe even thousands of collections of assets. But once we started to move into hundreds of thousands and eventually up to over 1 million within a year, it just, everything started to fall apart. We got really far behind in delivery. We had a bunch of cost overruns. We couldn't even find the resources nor afford them to get them into this larger program. And it just, we just watched things break once it got bigger. And so for us, we asked the question, how can we streamline this process in general by making the device smarter, smart enough to be intelligent and contextualized with all the information it needs, all the technology it needs, to actually make those, create those results right off of the camera or the device that's collecting the data. So how do we make it smarter? How do we move it from everything right now is move raw data up? How do we make it very purpose-built for those outputs and bring collection and decision-making a lot closer together for operational scale? So we built a platform which allows us to take all of these different technologies, wrap them into these little components, and then be able to connect them together with business logic to make it very specific and useful for the end user. And so, really for us, it was about creating process automation. We just watched so much time being spent in the field and in the office on these different use cases. How do we streamline that entire process? So the platform it's really built in 2 main pieces. We start with a no-code builder. It basically allows us to build full applications very, very quickly and also very flexibly and customized to whatever that specific end user needs. So all of these little blocks contain pieces of code. Some of those blocks are show UI. So we integrated a lot of Esri maps to show an Esri map if that's how the workflow needs to start. Other ones do things like process computer vision. So we've wrapped the YOLO framework, or even some of the newer small language models that are coming out. We can wrap all these technologies and not only leverage them in the application, but we can also connect them together in these automated workflows. So once we hit save, they download down to the device that's actually collecting with it. So whatever application we defined in the builder, we can put it down to the device that's actually collecting, whether that's a phone, a drone, maybe even a smart camera that's strapped to a car. And these workflows not only run these technologies, we have a lot of experience with computer vision, our team does, over the last 6 or 7 years. It's also about how do you apply all of that, because at the end of the day, those models are just giving you a bunch of detections. So how do you filter that down to exactly how you're going to use it in the business? And that's why we built all these logical blocks into it to allow us to get exactly what we want out of it. If that needs to be a geodatabase file that's in a very specific structure, you should be able to define everything, and everything should be done on the device. It's not always going to make all the decisions, but at least it's going to really drive the efficiency of the workflow by taking out all that human labor. So we built it as this big, wide platform where it could go to all these devices, all these use cases. We're still a young company, so we needed to make sure we had a good way to go to market. And by doing that, we started with some applications some use cases that we had worked in. We knew the problems with them, and how do we kind of add efficiency to them within the utility sector is kind of where we started. So the first 2 that we focused on are pre-design fielding as well as as-built verification. So in this case, we're drawing together a couple of components. One of them is augmented reality, wrapping Apple's ARKit. Another one is using the LiDAR from the iPhone that's embedding it into 2D photos. And then the third one is we're using AI to find the pole in some of the equipment to make the process more efficient. And so again, the process right now is they go out there with a 40-foot pole. and actually measure all the lines and get all the spatial information they need to go into the design. We've turned that into a 2 to 3 minute process with an iPhone. On the other side is the as-built. We're using some of the same underlying components, but instead of us not knowing what's out there, we can actually plug a design file into the application so it's sitting on the phone. It creates a task list of what needs to be, or what was, or what should have been added to this pole. The person going out there actually goes through that task list and measures those things or counts for them. And then it essentially spits out a Delta file of, was this built correctly within the rules that were set by the design file. A few other applications. Again, we started with utilities, but on the inventory management side, we did a lot of work here as well. A lot of the GIS databases, as well as the asset management databases, can be wrong often. So again, how do you have that as context in the workflow? You actually collect what's actually there, and then create the red, yellow, green of something should be here that isn't, or vice versa. And then obviously condition assessment. We're doing this with computer vision primarily, both on the ground, and then we can also run this on the drones. So that's kind of the next step, going back to our bread and butter from our previous company. How do we make drones smarter? We went 10 years with drones and they never had any idea why we were flying them. And then finally, this is really where we started. We waited a good year to even go to market because I think what we wanted was to build the entire underpinning of the platform, the architecture, to make sure that it could scale going forward. So we built a software developer kit to start with, and built on top of that. We built open APIs, and then basically it's bring anything that you want. If you have your own AI models, if you have your own database schemas, we wanted to be as open as possible on the platform so that it could connect to a lot of different technologies and use cases. And then finally, we got SOC 2 Type 2 earlier this year. We've done a ton of work in enterprise, so we knew that was going to be probably a prerequisite in a lot of cases. And then on top of that, like I said, we've built about 50 components that other developers can take advantage of. I won't go through all of these, but and they'll depend on the use case of how it plays out in the actual business case for something. But the cost and time on the labor side, on the I can't tell you how much we were paying Amazon once we were scaling computer vision in the cloud, and now we don't have costs anymore. It's your electricity. So it's really interesting to watch all of that efficiency play out. And then on the quality and standardization side, is just like every piece of this industry is apples to oranges. I'm sure you've all seen it. So we can also build these components to be these converters to say, how do you take a JSON file and put it into this exact, pole loading software format? Just make that seamless and build that in upfront. And then finally, on the business side, we're based out of Raleigh, North Carolina. Small team. We have about 5.5 right now. We started selling earlier this year, like end of March, so about 6 months ago. Right now, we're a little over 200,000 in annual recurring revenue. We should be at 350 by the end of the year, and we're planning to hit $1 million by H2 of next year. Our business model, we're still kind of testing things out. We're obviously early, but it's usage based, and we're actually selling blocks of time, and then they're actually consuming time on in the field when they're using the application. So we tried to line it up with labor as much as we could, just to make the business case development easier. And then finally, we've raised a little under $2 million in pre-seed funding, looking to start to warm up to close a seed round in Q1 of next year. Thank you.
Good. All right. Patrick, awesome. I gotta tell you, this is particularly of a passion of mine, because the second innovation project we did at Power was this. Okay, let me ask you some questions based on my experience. First of all, the market that you have right now, You probably know how massive it is. It's 7 million miles of linear assets just for electrical, right? And wires hanging around the United States. So the market is massive. I think you've tapped into something really big. Where we had a challenge was working with the individual clients and doing our training data sets and then getting the permissions to take those training data sets those clients gave us and using it with other clients. How have you gotten around this?
Yeah, so our first approach to it was set it up so that any of the ones that were starting to build their models could actually just bring it right in and we could leverage it right away. So that's kind of been our first approach. We have started to build out some models, but we really don't want to be in the model training business long term. It's a crowded space and there's lots of great people out there that can do it. But how we're thinking about kind of opening it up is they don't want to do it until they realize that there's some money on the table. And so we will be moving it into a marketplace where FPL wants to commercialize the models that they've developed. How do we pass that through to other folks that can get value out of it?
Okay, thank you.
Yep.
Yeah, great presentation. Thank you. My question is on your go-to-market. You mentioned you're still working on the business model, but how do you plan on being able to fill a funnel fast enough, top down, bottom up? How are you going to be finding customers? A lot of them can just take forever to close.
Yeah, so I mean, we did start with enterprise, and we probably should have started with SMB because you're right, it takes forever. But now that we've brought to market these very niche applications, it's really resonating well. We're now getting about 10 leads a week. And so some of those are big and some of those are smaller, but we're working with a lot of the bigger EPCs and some of the utilities on the construction verification side. But we've started to test out ads, but a lot of it's coming through organic LinkedIn, just content that we're putting out there right now.
Josh Estefano, DPR. Thank you. Great presentation. You mentioned enterprise a couple times, and I'm curious, kind of about your roadmap and integrations in the future. I work for a large organization. We're constantly concerned about data and our ecosystem. So I'm curious, where does that information go afterward?
Yeah, so we wanted to focus our value on the edge, on these devices. So we have some back end dashboarding and some Esri maps and things like that. But our focus was really to say, hey, we don't want to compete against Esri. Let's move it straight into Esri from the device. And so all that access is there where you can set it up from our data sync engine. You can push that anywhere you want.
Thank you.
Yeah.
Thanks, Patrick.
All right. Thank you so much, everyone, for being here today. Thank you, Matt, and the whole RCN team for putting this amazing conference together. And thank you to the Power Engineers team for organizing this pitch event. So first of all, who here drives a Tesla? Any hands? Not many Tesla drivers here. Normally I do this in the Bay Area, so there's a lot of Tesla drivers back. Okay, what about coffee drinkers? There we go. I love coffee drinkers. Why? You guys use a lot more power in the US heating up coffee every morning than charging Teslas. But that's changing. Our grid today is facing one of the fastest growth changes ever seen before. But when you turn on your coffee maker in the morning, you don't think about where that power comes from. The 200 million distribution poles across the US, another 200 million in Canada, that carry this power. These poles, look on the street, they're old, 50, 60, 70 years old. And they're crumbling, leaning over, touching trees. It's a problem. And how do we figure out which ones we want to work on? How do we figure out how to improve them? You take a measuring stick and you figure out how high they are. And then you take a piece of paper and spend 8 hours making notes. On the right, what you see is a San Diego Gas and Electric survey report as-built of a transmission tower that took 8 hours for a licensed land surveyor to do last quarter. We can do better. Last I checked, it's 2024. At Look, what we've developed is a fundamental hardware-enabled software technology. It all starts with the QCam. The QCam is a camera-only system, no LiDAR. Put those LiDARs far away from here. We believe in computer vision. These cameras go out and capture the imagery as you walk around. You plug in the system, hit start, and you walk. It takes an average of 45 seconds to about a minute to capture one power pole and the line adjacent to it. Orbit the pole, walk the line, orbit the pole, walk the line. An average of 250 poles per day for a single field technician. And out of it comes engineering-grade, survey-grade 3D data. And you may ask, who cares about survey-grade data? Don't we just want a simple set of measurements or things? Well, survey-grade data is important because engineering companies carry the liability of building things correctly. And that is where Look differentiates. Look is certified to be able to guarantee the quality so that any measurement you take is better than 1/100th of a foot, and globally georeferenced with its survey-grade GPS to better than 1/10th of a foot, right? And then the automatic AI that we've built in the cloud will take all those images, gather it together, and allow you to take geometric measurements across all of your assets. Is it clearances between transmission lines, distribution lines? Is it figuring out how close the line is to the tree? The diameter of the pole, because you need to figure out how big the pole is so that you can run structural analysis on it. And what's nice about that is that our AI will actually also figure out what is in the scene. It'll differentiate the line from the vegetation, and on top of that, figure out all the attachment points. And this is where the real magic happens, extracting all the engineering assets you need to be able to figure out whether this pole is structurally sound, whether it's going to fail with high wind, and whether you need to replace it. So altogether, we've built this very powerful technology stack. Fundamental, computer vision, capture very quickly, push it to the cloud, reconstruct it, have this digital twin to then go into engineering softwares, GIS, etc. And how do we make money? We're a startup. We've got to prioritize. We've got to make money fast. So we're laser focused. No pun intended here. We service survey companies and EPCs. They have engineering crews, field crews, linemen walking the lines on a daily basis, right? And we know when they have a contract saying, hey, by the way, power engineers, you have a contract where you need to collect 100,000 poles for this utility. Well, we can help them improve their project margins. 14, 15%, 48% is output. That is our story here. But that is not the story where it ends for Look. Look is building the data moats to be able to inform where in the future do we need to go. And that is the utilities that care about that. How do we use the information that we have gathered at large scale to do the work on the projects, but to be able to answer the bigger picture problems? And you may ask, haven't drones solved this problem? Right, they're everywhere. But let's look at a little bit on what really matters. When you're looking at a power line, right, you care about the detail. The guy wire, the little wire on the side of the pole that hangs down, that pulls it down. Whether that's in a ditch on the side of a road, you can't always see that. When your line is in a forest, right, and you fly a drone, you can't always see the line from all angles. And that is why PG&E, for example, they have over 1,000 field technicians walking the lines every single year. Look has the potential to change fundamentally how data capture is done at large scale to be able to guarantee the most engineering high-grade data for all downstream applications. So to date, we're about 3 years old. We announced the company in February, and we actually started shipping our product in July. We already have over 15 paying customers today using our product across the US, up in Canada, and our strategy is really land and expand. Get it adopted on a set of projects, prove the value, make them love it, make them live so that they can't live a second without it. Get them to buy more and more and more. We're becoming the tool that every single field truck in the industry is going to be using for fielding. And where are we going? And that is the potential Look is building. Our goal is to be able to use this information layer to build the insights play, and that's to the utilities. Being able to predict, hey, using all this information, what is the tensions in the line so that we can figure out this pole risk factor to the utility? Is it going to fail in 6 months, 12 months, 24 months? The assets combined into it, vegetation growth factor, all of that. And we're positioned to be able to solve that because of fundamental technological and data advantage to do that. So what we did, we looked at all the utility outages across the US. And the big parts you will see is that trees are a big problem. Branches, limbs touch the lines, and you get an outage. During a storm, you get an outage. And the other big part is equipment failure, right? Having your crossarm fail, line comes down. Having your guy wire slack, all those details. But what's good is that Look can fundamentally solve this. Look can go to a utility with the insights based on the data that we are able to drive and say, hey, let's now tell you and help you. How do we reduce this O&M spend? Because O&M is the devil to the utilities. They want to capitalize their expenses, rate cases, right? So we're helping them shift towards a proactive method to figure out how do we prioritize what needs to be solved to be able to defer O&M and make our grid more resilient. And that is a big opportunity for us. But this is not the end of Look again, right? Look's technology is fundamental. Our tech is used for anything survey. Is it transportation? Is it oil and gas? Is it real estate, right? It is a fundamental way of capturing 3D data that is accurate and scalable. You may ask, why are cameras so much better than LiDAR? Well, it's because of your cell phones. Your cell phones have been driving the cost of pixels down and processing down, right? And that's the fundamental principle we rely on. Same as Tesla, right? Our camera system will do over 100 million points per second. The best LiDAR system out there is about 500,000 to 1 million points per second. We're fundamentally changing how we can capture geospatial data at scale. So part of our journey, we're 3 years old today. We've gone to market this year. We've already booked over $500,000 in revenue this year, rapidly growing contracts that we're finishing end of the year about 1.2 billion. And that's just this guy doing the sales here, right? So the goal is not me doing the sales and grow our sales team, grow the company, and scale up, right? So we're at this early growth stage, very, very exciting part. We do actually have a C+ route open right now, and that's really where we're accelerating into the market. So with that said, I want you to go home, and next time you make a cup of coffee, think about where the power comes from. Thank you.
Okay, we were fighting over who gets the first question. So I'll take a crack at it. So can you clarify, when you say survey grade and engineering grade accuracy, can you be more specific? Because I got a follow-up.
Absolutely. So when a licensed land surveyor, a PLS certified surveyor, goes out and stamps a data set saying, hey, this data is survey grade, they carry the liability to ensure that the data set is geometrically consistent to the specification around the data. Generally in the US, that is considered about 1/10 of a foot global positioning, where on Earth it is, and then relative distance measurements about 1/100 of a foot. Certain cases, you want to be tighter tolerance, like 88 ramps and stuff like that. But generally speaking, that is survey grade.
So Leica must be nervous.
Sorry?
If you're saying you have a photogrammetric tool that's survey grade, Leica must be nervous. Now, just to be clear, I believe that photogrammetry at some point, combined with AI, Gaussian splat, whatever, is going to be taking over the world and probably taking the place of LiDAR. But that's me. That's my only opinion. But today, are you claiming that your technology is as accurate as a stationary Leica technology? Just want to be clear.
So I challenge everyone to come out and try our technology and scan outside. And what you will see is that our point density is closer down about 1 millimeter to millimeter. Most of our data that we publish to our clients are downsampled by 10-fold because most tools today don't even know how to handle the data intensity. We can guarantee that come out of it. What we've solved at Look is what has been inherent difficulty in photogrammetry: doubling, misalignments, warping, global warping. And why have we solved that? Because of this. We're the crazy people that actually build hardware, right? We have geometric constraints in our system that allow us to constrain the photogrammetry and alignments to guarantee the data quality that comes out of it.
Cool. Thank you.
Are there any challenges around either human error when collecting the data, or you talked about one of the biggest issues being kind of trees encroaching on the lines? If the lines, a lot of the pictures you showed, lines were kind of out in the middle, no trees around them. But if they're in a bunch of trees. Are there any challenges in terms of collecting the data around that? And then I have a second question after that.
Absolutely. I mean, certain lines are in backyards. It's a huge thing. And what we've seen a lot of engineering firms trying to capture backyard data or lines in canyons and all that. And guess what happens? They go hike out there and they collect the data. Because if you need to figure out what is there, you got to collect the data, right? You cannot always buzz a drone down to eye level to figure out the pole tag or the guy wire stake in the back, right? And that detail matters. So what we found is that, hey, it would be nice to just take high-level data. Sometimes you just got to go boots on the ground and figure it out.
And then the second question is there a next level opportunity to get this on a car and do 10x in a day, or is that just technologically not feasible?
Yes. Stay tuned.
Awesome.
Did you have any challenges with manufacturing? Any defects in the first production run, or any challenges there?
Yeah. So you see our little prototypes on the left. So we started with a rover, and then we're like, robots suck. Humans are great. So we went handheld, and then it started working, right? But there was a lot of considerations, everything from thermals to waterproofing to industrial housing, right? Like this device here, right, is industrial. Gorilla Glass, so it doesn't scratch. Very easy phone mount that you put on, right? So we really thought through the product and iterated about 12 times to get us to what is today our production unit.
By the way, great use. I'm on. All right. Great use of the quad lock system. I know that phone mount. I have a pretty basic question for you. Does it work indoors, and how well?
I didn't see that question coming. No, I did.
I'm sure you get that one all the time.
We are very focused from a business perspective and a technology perspective to serve a great vertical to begin with, and that's exterior, right? We're focused on survey. We're focused on overhead utilities because that is where our technology is an incredible disruptor, right? I'm excited to go back on the interior space, so stay tuned for that as well. But today we're really focused on exterior.
Thank you.
Can you really quickly just touch on unit economics? How do you charge customers?
Yeah, so we've switched to a unlimited data processing. So you get one of these devices as part of our software plan, and with that you capture as much as you want every day, as much as you want, and the data goes to the cloud, or AI processes it, and that's what our costs are, is cloud processing. And then the hardware gets amortized. Think about like a lease, where they get the hardware as part of the software subscription on average about 3 years. So,
thank you.
Do you think you'll ever go back to try to automate it with robotics?
In parts, yes. I think it's going to be very specific where and how. I see a lot of opportunity on road-based capture for scalability. I see a lot of opportunity from some certain aerial perspectives. I see a lot of opportunity for certain difficult to access conditions, government conditions in areas. So that's definitely an area we do support. And you can put this on a spot. Many people do that. But humans are great capture devices, or people also. Any other questions?
Yeah, done.
One more?
Last one.
All right, I gotta ask. I know you have a GPS unit on top of that, and I'm curious. You need a base station. What is the calibration? What's the of that unit? Because I'm familiar with how those things work. But do you have a base station that thing works with, or were you just getting post processing? How does that work?
Great question. So you have a bit of a survey background or engineering background. So this is a triple band GPS receiver and antenna L1, L2, L5. We do raw GPS observations on the system that get encoded in our data format, and then everything is post-processed. So think of it like a PPK, PPP hybrid that combines open source and closed source correction services where available to guarantee the data quality. So this is equivalent to a high-end differential GPS system as well.
Okay, thank you.
All right,
Thank you very much.
Thank you so much.